Okay, guys, it's Mrs. Millison again. Let's go over the check your understanding on page 181. Some data was collected on the weight of a male white laboratory rat for the first 25 weeks after its birth. A scatter plot of Y, which is my response, which is weight, and X, which is my explanatory, time since birth in weeks, shows a fairly strong positive linear relationship. So my correlation would be closer to 1 and positive. The regression equation is y hat equals 100 plus 40x, and that models the data fairly well, okay? So let's predict the rat's weight at 16 weeks old, okay? So first thing I want to do is jot down that regression equation. So y hat equals 100 plus 40x. X is my explanatory, which is the time since birth, and that is in weeks. And y hat is my predicted weight, right? And that is in grams, okay? Whenever you write a regression equation, always identify x and y, explanatory and response. We're using time since birth in weeks to predict a rat's weight. So it says predict the rat's weight at 16 weeks old. So all I have to do is plug 16 in for x. Pretty straightforward. Plug that in the calculator and we get 740 grams. Okay, so from our data, we're going to predict that a 16-week-old rat is going to weigh 740 grams. Okay, well, let's calculate and interpret the residual if the rat actually weighed 700 grams at 16 weeks. So our rat at 16 weeks weighed 700 grams, okay? So our rat at 16 weeks weighed 700 grams. Remember, I would have predicted he would have weighed 740. So our residual is just the difference. It's the actual weight minus the predicted weight. It's the y, it's the actual, minus the y hat, the predicted. Okay, so my residual here will be 700 minus 740. So my residual is negative 40 grams. Okay, there's a difference of 40 grams. Now to interpret that, I kind of interpret it just the way I say it, just the way I see it. I say the 16-week-old rat actually weighed 40 grams less than I would have predicted, okay? So the 16-week-old rat actually weighed 40 grams less, and I say less because it's negative, so you won't put negative in your interpretation, 40 grams less than I would have predicted. Okay, and then I'm going to say using the regression line. Okay. All right, so that's how we interpret residual. If it had been a positive difference, I would have said the actual weight was 40 grams more than I would have predicted. Okay, but again, I just interpret it just the way I see it. The actual weight is 40 grams less than I would have predicted. Okay, so let's look at number 3. Now, should you use this line to predict the rat's weight at 2 years old? Okay, all right, 2 years old. Let's think about that. 2 years is what, 104 weeks, because there's 52 weeks in a year. So 104 weeks. Well, our data that we collected was just within the first 25 weeks. So 104 weeks is way outside the scope of our data. Okay, and if we make a prediction that's way outside the scope of our data, that's not really proper, okay? And that's called extrapolation. So we really shouldn't use it, okay? 104 weeks is way outside the scope of our data, since our data only went up to 25 weeks, since our data was collected, that's a C, up to 25 weeks. Okay, so this is called, this is extrapolation. 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 Oops, sorry guys, I keep forgetting to move my paper over. So this is called, this is extrapolation, and shouldn't be used. Oops, shoe. It shouldn't be done. Okay, well, let's see why. And then it says, use the equation to make the predictions and trust your confidence in the results. Well, I'm telling you right now, I'm not going to have any confidence in these results because 104 weeks is way past 25 weeks. So, let me pull my paper. So if I do use my regression line to make that prediction, remember my regression equation, okay, and X was the weeks. So if I plug in 104 weeks here, I'm going to get a predicted weight of 4,260 grams, okay, at 2 years, at 104 weeks. Well, 4,260 grams, okay, again, we're in America, I have no concept what a gram is, but a pound I do. So if I convert this to pounds, 1 pound is something, 454 grams. So this ends up being, holy moly, a 9-pound rat, okay? That's huge. That's a big old rat, okay? That's like a little smaller than the typical cat, all right? So this is why I have no confidence in this prediction, okay? Because that is way too big, because 104 weeks is way too far out of the scope of our data. So this is extrapolation. I shouldn't have done it, and I'm not very confident in this prediction at all. Okay, when we did the prediction above here at 16 weeks, that is within 25 weeks. So I'm very confident on where am I? I'm very confident on that prediction. Okay, all right, guys. I hope this was helpful, and I shall see you next time.